In this video, we're going to talk about using algebra and arithmetic to graph equations, different equations in the coordinate in the rectangular coordinate system. Different equations graph different types of graphs. Some are just straight lines, some are curves, some could be circles. Different things, different relationships that an equation will give you when you try to make coordinates or points that will satisfy any equation in two variables. Now remember, if you're going to try to graph an equation in the coordinate plane, it really kind of needs to have two variables when you're doing so. If it only has one variable, it's probably going to be either a vertical line or a horizontal line. But in this case, we have both x and y, so I can come up with different points here to plot just by picking any value I want to for either x or for y. But one thing that I always kind of find handy is taking the equation first and solving it for one specific variable. Most of the time for the y. Y seems to be the best variable to solve for. So let's do that. To solve this equation for y, we're going to do a little algebra on it. So if you remember solving equations, if I'm trying to get the y by itself, I'm going to move the 6x over, so I'm going to subtract 6x from both sides. So I have negative 2y equal to 12 minus 6x, and those can't be subtracted because they are not like terms. And then lastly, I want to divide by the negative 2, so I'm going to divide everything by negative 2. Hopefully that'll get me in a better shape to plug numbers in. So y equals negative 6, and then negative 6 divided by negative 2 would be plus 3x. So since I have solved this for y becomes what we call the dependent variable, and x would be the independent variable. In this case, independent means I can plug any number I want to in for x, and when I work it out, whatever I get, whatever x is, whatever y is depends on whatever x is. So it's dependent upon whatever x is. So I'm just going to pick some numbers out of my hat, just some easy numbers to work with. Let's make it as easy as we can. 0, 1, 2, 3. Can't make numbers any easier than that. So if I plug those or substitute those into this equation, what will we get as output values for the y equation? So if I put 0 in for x, that would be negative 6 plus 3 times 0. So negative 6 plus 0. So we're just going to get negative 6 out of it. If I plug in a 1, negative 6 plus 3. So negative 6 plus 3 would be negative 3. If I were to plug in 2, negative 6 plus 6 would give me 0. And as you can see, you're doing the same thing throughout the process here. So negative 6 plus 3 times 3. So that would be negative 6 plus 9, which would give me 3. So now if I plot those ordered pairs, you're going to get an idea of what the relation will look like as a graph, what the equation looks like graphed in this case. So 0, negative 6, that's a point on the y-axis. Over 1 down 3, so the point 1, negative 3. 2, 0, so over 2, and I don't go up or down at all. And then 3, 3, we're going to go over 3 to the right and then up 3. So actually what I have in this equation is a line, it looks like, a linear equation. Put arrows on the end because they're lines. So 6x minus 2y equals 12 is going to graph a line. Notice your x and y are to the first power. You'll study later that lines always have x to the first power and y to the first power. Let's look at a different type of relationship. In this one, we have it already solved for y, so that's very helpful for us. But you have x squared, so you have a higher power than 1, and then plus 2. So again, since it's solved for y in terms of x, we can say x is the independent variable, and y depends on whatever x is. So it's dependent. So I'm just going to pick some easy numbers to plug in again. So how about let's plug in a 0, 1, 2, 3. You can't beat that. That's pretty easy to work with. So if I plug those numbers into the equation for the example, if we do the first one, y equals 0 squared plus 2, then y will equal just 2. Or y equals 1 squared plus 2. So that would be 1 plus 2, which is 3. Try 2. Y equals 2 squared plus 2. So that's 4 plus 2, or 6. And let's try the 3. 3 squared plus 2, so that's 9 plus 2, which is 11. Let's see what we get here. 0, 2. We know that is a point on the y-axis. 1, 3, so over 1 up 3. 2, 6. So it's not necessarily a line anymore, is it? Over 3 up 11, so 11 is going to be up here a little higher. So it looks like it's kind of a curved. Wonder what it would do on the other side of that line. Let's try one more point on our list and see what happens. If I were to pick negative 1 for x, what would have happened? So let's say y equals negative 1 squared plus 2, which that would make positive 1 plus 2, which is 3. So we're getting another y value of 3. So at negative 1, you go up to 3. So it looks like my graph is a U shape, probably symmetric on both sides. This is actually called a parabola. Graphs where one of your variables is squared and the other one is not will always graph this U-shaped curve called a parabola. Let me write that out so you can see what that word looks like. Not parabola, but parabola is how you say that. Let's do one more just to play around with graphing these equations. This is a twist. We haven't seen one where you had x solved for. In this case, x is your dependent variable because it's solved in terms of y variables. So y is what we're going to plug into this time and solve it in order to get x. So I'm just going to do the same thing I've been doing. We'll plug in some numbers, let's say. Now, I see something here. If I just were to go down through here putting 0, 1, 2, and 3, I would be in trouble. Let's just show you what I'm talking about. If I were to plug 0 in for y, 0 minus 3 is negative 3. The square root of negative 3, we remember that as an imaginary number, so it would be nothing that I could plot in this coordinate system. So I'm going to have to pick numbers that will work here. So I'm going to pick, instead of something so low, let's pick something where we know we'll get a positive number. So I'm going to start out with 4. I could do 5. 5 minus 3 would be 2, so the square root of 2, well, let's go ahead and try it. 5, 6, 7. We'll try it and see how it works, okay? So if I plug in the 4, x equals the square root of 4 minus 3, which is the square root of 1, which we know is just 1. Okay? If we do x equals 5, 5 minus 3, x would equal the square root of 2, which is approximately 1.41. So we'll just have to kind of guesstimate that. X equals the 6 minus 3, the square root of 3. Let's see, using my calculator, the square root of 3 comes out to be like 1.73. And then 7, let's try that last one. The square x equals the square root of 7 minus 3, which is the square root of 4, which we know is 2. So let's see if we can get an idea of what the graph of that equation is going to look like. If I plot the point 1, 4, over 1 up 4, over 1, almost 1.5 up 5, so not quite 1.5 up 5, 1.73, and go up 6, so almost 2. Okay, and then 2, 7. So it looks like it's a curve also. So it could be that we could find some points that actually, it makes me wonder if I were to pick any points. I can't pick any points for y that are less than 3. But that looks like it's going to do a curve like so. So just to give you an idea of what that graph's going to look like.